Question 2. For each pair of the functions below, obtain an expression in the form of function notation for fg, gf, f square, g square. Right, let's do A first. So let's find what is fgx. So if fx is 3x, fy would be 3y, fz will be 3z. So fgx will be 3 of gx. Then we know gx is 3 minus x, so you can put this into the gx. Gx is 3 minus x. So this will give us 9 minus 3x. Okay, next. So fg done, next gf. So gx is 3 minus x, gy would be 3 minus y, gz 3 minus z, gfx will be 3 minus fx. And we know fx is 3x, so you put this into the fx. So it's simply 3 minus 3x. That's all. Okay, it's done. Next, f square. So f square x is the same as f of fx. So fx is 3x, fy is 3y, so f of fx would be 3 of fx. And then fx is 3x, so we sub this into the fx, so you get 3, 3x, you get 9x. And lastly, g square. So g square x is the same as gx, so it's the same thing. Gx is 3 minus x, so gx would be 3 minus gx. Then gx is 3 minus x, so we sub this in. So this will give us x. That's it. Right. Now we try B. Okay, so fgx. So if fx is 4 plus 2x, fgx would be 4 plus 2gx. Then we sub the gx into this. So gx is x square. We put x square here. 4 plus 2x square. Next, gfx. So if gx is x square, gy is y square, gz is z square, gfx would be fx square. We know fx is this, so we sub this into the bracket. So 4 plus 2x square. Then this one we expand. So when we are expanding square, we will get 3 different terms. The first term would be 4 square. So 4 square is 16. The last term would be 2x square. So 2x square will be 4x square. And the middle term here would be 2 times 4 times 2x. So 2 times 4 is 8, 8 times 2x is 16x. So this is the shortcut to square. So this is the answer. You want to rewrite it also can. 4x squared plus 16x plus 16. Okay. Next, so this two done, f squared. So f squared x is the same as fx. So fx is 4 plus 2x. Fy would be 4 plus 2y. Fgx would be 4 plus 2gx. Fx would be 4 plus 2fx. Okay. So let's sub the fx inside. So we know fx is 4 plus 2x. We have to put it into this fx. Not enough space. Let's bring this a bit here. So 4 plus 2x. We expand this. 4 plus 8 plus 4x. We get 12 plus 4x. And lastly, g squared. So g squared x is the same as gx. So gx is x squared. Gy would be y squared. So gx would be gx squared. And then gx is x squared. We sub this into the gx. So it will be x squared squared. So this will be x power 4. Done. Okay. Next, C. Fgx. So Fgx is, if fx is x plus 4, fy is y plus 4, fgx would be gx plus 4. And we know gx is this, so we put this into the gx here. So 6 over x plus 4. Okay, so when you get x in your denominator for functions, you must state the condition. X cannot be something. So you must remember your denominator cannot be 0. Therefore, x cannot be 0. Okay, so this whole thing is our answer. Okay. Next, so fgx done. Next is gfx. So if gx is 6 over x, gy is 6 over y, gfx would be 6 over fx. And we know fx is this. We take this, put it into the fx. So 6 over x plus 4. So in this case, x cannot be negative 4. Because your denominator cannot be 0. So if x is negative 4 plus 4 will be 0, right? So x cannot be negative 4. Next, f squared. So f squared is f of fx. So let me write this again. F squared x is f of fx. So we know fx is x plus 4, fy would be y plus 4, fgx would be gx plus 4, fx would be fx plus 4. Then we take the fx, we put it into the fx. So x plus 4 plus 4, x plus 8. Then lastly, g squared. So g square x is g of gx. If gx is 6 over x, g fx 6 over fx, g gx would be 6 over gx. Then we take the gx, we sub into this gx. So 6 over x. Okay. So this would be 6 divided by 6 over x, which is the same as 6 times x over 6. So this one we can cut, we will get x. So g square x is just x. Done. All right. Lastly, question D. f gx. So if fx is x minus 5, f gx would be gx minus 5. And we know gx is this whole thing, so we have to put this in here. So 1 over x minus 1 minus 5. You can leave it like that, or if you want to make it into one single fraction also can. Okay, so let's see how to make it into a single fraction. This is 5 over 1, so our denominators must be same. That means we must times top and bottom by x minus 1. So here our denominator will now be same. Our numerator will be 1 minus this. So 1 minus 5x plus 5, which gives us 6 minus 5x over x minus 1. So here, don't forget your condition. Our denominator cannot be 0. So if x is 1, our denominator will be 0, right? So x cannot be 1. Okay. Next. G f x. So if gx is this, x minus 1, gy would be y minus 1, gfx would be fx minus 1. So now we know fx is this, we take this and put it into the fx. So this will give us x minus 6. So condition is x cannot be 6, because 6 minus 6 will give us 0. So denominator cannot be 0. So this is our answer. Right. Let me erase this. Okay, last two. F square. So f square x is f of fx. So if fx is x minus 5, f of fx would be fx minus 5. Then we put in the fx into here, we would get x minus 5 minus 5, x minus 10. And lastly, g square x. So g square x is ggx. Okay, this one is a bit tricky. So gx is x minus 1, gy would be y minus 1, ggx would be gx minus 1. So 1 over gx minus 1. Now we sub this gx into here. We will get 1 over x minus 1 minus 1. So here now we need to make the denominator same to make it into one single fraction. So 1 we can change it to x minus 1, x minus 1. Okay, the 1 we times by x minus 1 now. Okay, now we will be getting 1 over 1 minus x minus 1 over x minus 1. So if you have 1 over this means, that means it's the inverse of this. Okay, anything with 1 over means it's inverse. So our answer is just x minus 1 over. So this one we terbalik lah. So x minus 1 will be on top. And then this one will be in the denominator. Okay, 1 minus x plus 1. So this one we can simplify it. So 1 plus 1 is 2. 2 minus x. Okay, then we need to state the condition. Oh, not enough space here. I write down here. X cannot be 2. Because if x is 2, 2 minus 2 will become 0. Okay, so this is our answer and this is the condition. Okay, so you write them next to each other lah. Here got not enough space, but you're supposed to write it like this. Okay, you must write it in one single line like this. Done.